Hello fans of GeoGebra. We have an indeterminate problem that we will solve without any statics whatsoever. We are post-statics here at Cal Poly. Okay, so the problem is this. It's a beam propped up at the left here and fixed at the right. So we call that a propped cantilever. There are 2 point loads on the beam that I can control the magnitude of the forces. I can also control the location. And as always in Mueller-Breslau, I find the loft. And that is, how would this load travel in the perturbed situation? The perturbation is happening because I am seeking M at the fixed wall right support. So as always, I induce a unit perturbation. Here I'm using 45 degrees. I know that's not 1 radian, but it makes sense to me. S is equal to R theta. So S is equal to R for this unit perturbation, and theta is 45 degrees. What I did was I took half of that, 22.5, and you'll see why I need that, and I took half of that again on this side, 22.5. Where those two lines intersect, I'm calling that forced 2. It's a point that I could just draw on a napkin. Literally, I could draw this on a napkin. Because fixed, pinned, I have a 45, I have a 22.5, and then I have this forced point here. There's 2 more points. One of them is on this 45 degree line, and the other one is on the other 45 degree line. So I have the left point, the forced one, which is on the 20, sorry, did I say 45? The left point, the forced one, which is on the 22.5 degree line, the forced 3, which is on the 45 degree line, and then the forced 2, which is at the two 22.5s. And then I just splined between the 5 points. 1 point, another point, a third point, a fourth point, and a fifth point, in honor of C.K. Wang, my professor at University of Wisconsin, who used to do this with balsa wood and push on his fingers, with his fingers on the balsa wood. And then we just find the loft here, this geometric loft. And the moment is the first force times the first loft plus the second force times the second loft. And it's kind of unbelievable, right? You could see the lofts there. And I'm having 3% error, ladies and gentlemen, to theory. Maybe 7, 8%, maybe 6%, but it looks like it's under 10% error the whole time because I am doing this on a napkin sketch at Scout Coffee, the finest coffee in San Luis Obispo. Please go visit them. Maybe I'll get a free coffee. So it's pretty exciting, I think, that a problem like this would give most structural engineering students some heartache, I think. I bet you many of them would get it wrong. I'm just guessing. Maybe not the Cal Poly students, but... Okay, I hope you loved this video.